Welcome to the Advancing Excellence podcast. In this episode, we're diving into the evolution of head protection in the construction industry with none other than Scott Greenhaus, a leader in safety innovation and engineering excellence. Let's begin the podcast.
Welcome to the Advancing Excellence podcast. Today we're joined by Scott Greenhaus, Senior Advisor with Structural Group, a leading construction technology and service provider specializing in concrete repair, strengthening, and engineering systems across the U.S., Canada, and the Middle East. Scott is also the principal of SMG Solutions, LLC, and holds degrees in civil engineering and an MBA from the University of Maryland. With a distinguished career, including serving as Executive Vice President and Chief Risk Officer of Structural Group, Scott has been a driving force in advancing safety and innovation in the construction industry. He chairs the University of Maryland Engineering Board of Visitors and has held leadership roles with organizations like the Post-Tensioning Institute, International Concrete Repair Institute, and the American Society of Concrete Contractors. A prolific author and speaker, Scott has contributed extensively to topics like concrete repair, safety culture, and mental health in construction. Scott, welcome to the podcast.
Thank you, Janice.
So let's start with a bit of history. How did the hard hat come to be, and what was its original purpose in the construction industry?
Okay. Well, hard hats go back actually to the 1920s. And the very first hard hat was called a hard-boiled hat. And the reason why it was called a hard-boiled hat is because it was manufactured from steamed canvas, glue, had a leather brim, and black paint. So that kind of hardened into a protective hat. And that evolved then into the 1930s on the Golden Gate Bridge project, which was the very first mandatory hard hat site. And those hard hats were made of aluminum, so it was still lightweight but protective if somebody would drop a rivet from above as they were constructing the bridge. And then moving to the 1940s, the MSA company brought out what's called a skull guard cap or skull cap, which is made of fiberglass. So a little different material approach to hard hats. And that kind of stayed the same until the early 1960s, where there was a top guard hat, which is made of polycarbonate plastic. And in 1962, what we would see as the typical hard hat, which was called the V-guard hard hat. And that's pretty much stayed the same all the way to the present day. So the current hard hats that we wear have their genesis back to the early 1960s. So 45 years or 45 years of not changing at all. And in 1982, a ratchet was added to the hard hats in order so you could tighten it to your head. But that's been the technology. It's very old technology. And, as we move forward, we'll talk about some different technologies.
Okay, yeah, so interesting. So my next question, what inspired your involvement in the Head to Helmet initiative, or H2H, and why is this transition so important to you?
Yeah, so in construction, we've all used the typical hard hat for all these years, and certainly for all of my career. And then what changed for us, and what changes for a lot of people regarding safety, is an incident that occurred. And our team was working on a project in 2018 on a bridge construction project in Florida. And it was a very unique structure that was being built. It was a concrete truss that was post-tensioned in nature, cast on the side of the road, and then moved into place with mobile travelers. And our team's responsibility on that job was to furnish and install this high-strain steel post-tensioning system, which we did. And really early on in the construction of this structure, which was actually precast in place, there were some cracks that showed up when the structure was put into place over a very busy roadway. some more cracks showed up, and when it was set down on the piers, it cracked quite a bit. And so our superintendent on the job notified the project manager for the general contractor, hey, there's been a lot of cracks in the diaphragm at the abutment. You need to look into this. And then we were done with work and we left the site. While we were away, those cracks got wider and wider and deeper, such that you could put your hand into it. So the concrete structure was screaming, hey, I've got a problem here. And the contractor called us back to the job site. We said we need assurances from the engineer that it would be safe to work on, because they wanted to sort of post-tension the cracks back together. We got those assurances. They said it's no problem. This is going to be something that we should do. So we did come back, and while we were re-stressing the tendons, the bridge collapsed.
Oh my goodness.
And it collapsed, killing 5 pedestrians or people in their cars below the bridge. Cars were crushed, and one of our team members was killed when the structure collapsed. And the superintendent on the job, well-known superintendent, worked in this specialized area, was severely injured with a significant traumatic brain injury. And they thought at the time that he would be in a persistent vegetative state. In the ensuing years, there's been some improvement, so he can walk and limited communication, but 24-hour help is needed, and his life has completely changed, and that of his family and friends. And when we visited a site the following day, we noticed that their hard hats were on the ground adjacent to the collapsed structure. And then we started to think, well, what would have happened? Would there have been a different outcome had they been wearing construction helmets, which we were familiar with from other places in the world, not the US, but other places? And had they been wearing a protective helmet, would there have been a different outcome? And we'll never know that for sure, but that event, and then subsequent to that, as we dug deeper into what helmets could do for the construction worker, that launched us on this Hard Hats to Helmets initiative.
Okay. So from your perspective, what limitations or safety concerns have been associated with the traditional hard hat?
Yeah, so the traditional hard hat, a little bit as I described, has been around for quite some time, and it's tested primarily for impact absorption and penetration resistance. So what does that mean? That means if something is dropped directly on top of your head from overhead, say a hammer, a wrench, or a small piece of concrete, something like that, and it impacts the top of your head, the hard hat is designed to protect the hard hat from crushing into your head or your head being damaged at a certain energy level, and that that there's no penetration through the helmet, through the hard hat. So say you drop a screwdriver, and that it doesn't penetrate into your head through the hard hat. So there is no requirement on what's called an ANSI Type 1 hard hat, which we've all used for all these years. For side impact, there is no protective liner system. There's no chin strap. So the traditional hard hat is meant sort of primarily for impact to the top of the head only.
Okay. So walk us through the advancements helmets bring to the table in terms of safety and functionality.
Okay. So if you think about things that are done outside of construction, so say you're going to ride your bike or go skiing or snowmobiling or riding a horse or a motorcycle, what's the difference? What protective equipment do you use? Well, almost in all cases, you're going to be wearing a helmet. And those helmets for these sporting activities, football certainly is the most well known,
Hmm.
where there's been issues regarding head injuries in helmets. But they have energy absorbing liner systems within a helmet that the typical hard hat or traditional hard hat did not have. And those energy absorbing systems, which could be a polystyrene foam or other types of materials to absorb the energy of a fall, those protect the head from skull fractures and brain injuries. Certainly nothing is 100%, but it adds greater protection. The other thing that you get out of a helmet is a chin strap. It's got to stay on your head in order to protect your head. So the chin straps are very important to maintain the position of the helmet on your head. Should there be a fall, should you get struck by an object. So the difference between hard hat and helmets is the level of energy absorption where on your head an impact might occur. So it's designed to have resist impacts from not only the top, but the sides, the front, sort of circumferentially around the hard hat. So that is the greater amount of protection that you get from a helmet as opposed to a hard hat.
Okay, so that kind of leads me into my next question. One of the key innovations in helmets is their ability to manage rotational impact. Can you explain how this technology works and why it's a game changer?
Sure. So what I've talked about is sort of this impact absorption and penetration resistance, and those are tests that are done, should an object strike your head. What happens in an actual, say, a fall, could be a slip, trip, or fall, a fall from a height, or riding a bicycle or riding a horse, is that you never generally do not fall, sort of directly on top of your head. You fall at an angle, and that angle creates a impact not only to your head, but also your head rotates within either if you're well, certainly if you're not wearing a helmet, there's going to be severe injury. But even if you're wearing a helmet, there's a rotation of your head in the milliseconds that happen during a fall. And the damage that's done to the brain is really from this obtuse angle strike to the ground where your head is rotating and your brain is rotating inside your head between your brain and your skull. It's a thin membrane. And as these rotational forces are happening, the brain is moving within your skull, and it is being sort of dragged along your skull, which causes a shearing action. And that shearing action is what actually causes the damage to the fibers of your brain. And so, if we could limit the amount of rotation that happens within those milliseconds of a fall and dissipate that energy, we can reduce the damage that's occurring between your brain and your skull as there's a fall. And there's a couple different ways to mitigate this rotational damage that happens as you're falling. There's what's called a MIPS system, which is multi-directional impact protection system. And a MIPS system is a low friction layer. It's a very thin layer of plastic material, which is attached to your hard hat. And that thin layer of plastic allows about 6 millimeters of rotation to occur during that critical time when you're falling and you're hitting the ground. And that allows for rotation of your head within the helmet. So so you don't have as much shearing action between your brain and your skull. It's your head and the helmet. So it actually moves independently of that. And that helps to absorb the damage that can happen. So that's one methodology that's used, and that's used quite frequently. It's just starting to be used in construction helmets. but it's very frequently used in bicycle helmets and ski helmets. Another technology that's fairly new that's come onto the scene is the cellular technology. There's a couple different types of materials that use this cellular material, which is a plastic. So think of a honeycomb shape that's fairly thin in nature. That's a liner inside the helmet, and that honeycomb sits on top of your head. And the way the honeycomb system works is when you fall, you have these radial and tangential loads that are occurring to your head, and the cells of the honeycomb will either crush or crease, depending on if you're hitting if you have a direct crash and you're smacking right into it, or if you're rotating, they'll crease, they'll fold over, and these cells all work together and they move and they crush and they crease, and that is what absorbs the energy from the fall.
The
So the
impact
whole
of the
idea
fall.
here is to be able to dissipate this rotational energy that has to go somewhere. So we want it to go into the helmet system rather than into the interior of your head.
Right. That's so smart. So let's talk about comfort. It's always a concern for workers. How do helmets compare to hard hats in terms of wearability, especially in challenging environments?
Yeah, so our history has been in the years that we've been using helmets, and certainly I've talked to a lot of contractors and field people over these ensuing years as there's been a gradual transition from harness helmets. I think it's safe to say that the consensus is that helmets are more comfortable than hard hats. That is generally what's been said. Um, they are slightly heavier. Obviously, there's more material within a helmet than a hard hat. Some of that small amount of extra weight is offset by the distribution of where the weight is on your head, how it sits on your head. So I'm not familiar with any real issues regarding comfort, other than it's at least equivalent to or more comfortable, and that's obviously a taste and feel kind of thing. So, but most people will say the same thing. The bigger concern has been with temperature effects, and our helmets hotter than hard hats, and some helmets have a suspension system that moves the helmet away from your head. Also has an energy impacting liner, which allows airflow through. Some of the systems have channels in the energy absorbing liner to let airflow. But most of the concern that I've heard about helmets is that they're hotter than hard hats. And so what we have here is, perhaps there's a perceptual issue, uh, and perhaps there's something to that. There hasn't been exhaustive studies on heat. There's a study that was done by Georgia Tech several years ago where they took helmets and the traditional hard hats. They had measurements that were taken. They had thermocouples in the hard hats. They had wet sponges to simulate perspiration that somebody might have, from working. And they put them outside. They had various temperatures. The Georgia Tech study showed that the hard hats and the helmets had very little difference in internal temperature. Um, our company did a study, not scientific like Georgia Tech, but we did put hard hats and helmets out on several hot days. We found that the helmets were actually cooler on the inside than the hard hats, and we believe that was through some of the insulating effect of the foam material. But others have done some measurements and found that they were hotter. So it's something that's being studied at the university level. So we hope over the next year or so to have more information regarding this. The important thing is, even if you perceive it's hotter, then it's hotter to the individual. So
Right.
manufacturers are working on ways to have more airflow. Some are even putting fans into the helmets.
That'd be
which
interesting.
is
Is there a way for them to incorporate cooling material into the helmet?
Well, that's a good question. And one of the things I wanted to point out is, so we might be talking, I mean, so certainly the studies I've seen, which again are not exhaustive, so you might be talking a couple of degrees here and there between the hard hats and the helmets. The bigger issue is the color. So what's well documented is dark colors such as black, red, and blue are significantly hotter. They absorb more heat energy, radiant heat energy, than say a white hard hat or a white helmet. And that could be significant. It could be from 6 to 9 degrees hotter
Oh, wow.
inside a say a black, a red, or a blue hard hat or a helmet than it is white. So while the jury's still out as to exactly whether it's a little bit hotter or a little bit cooler on the inside, the big thing that we're missing is the color of that right now. So if you want to make a big difference and keep the people cooler, then color makes, as far as I can tell right now, a bigger difference than whether you're using a hard hat or a helmet.
Gotcha. So my next question, what role do regulatory standards play in driving the adoption of helmets? Are there any specific guidelines companies should be aware of?
Well, that's good. That's also a good question. The regulatory thing is a pretty interesting issue. I mean, right now, helmets are, so you refer back to OSHA, and OSHA in its standards refers back to ANSI. And ANSI standard for hard hats and helmets or head protection is Z89.1. And in Z89.1, there's two types of helmets or hard hats listed, type 1 and type 2. And as I mentioned, what we've always used in the construction industry is type 1 hard hats, which is just tested for the top impact absorption and penetration. Type 2 hard hats, which also have what's called impact attenuation. So if you fall, so there's measurements of that, and they have a protective liner. And right now it's optional as to whether you have a chin strap. Obviously, that needs to be sort of a mandatory. But up until just right around when this incident occurred, I know in my 45 years of construction, I had never seen a type 2 hard hat used in the U.S. And I had heard some usage of type 2 up in Canada in rail projects, but never in the U.S. So the regulatory process, it starts in a group called ISEA, International Safety Equipment Association. They develop the requirements. Those are then reviewed and adopted by ANSI, and ANSI standards are then referred to by OSHA. So as we've gone into this movement of hard hats to helmets, initially everything that you use in the U.S. has to meet the OSHA and ANSI standards. So the Type 1 hard hat had to be met as a minimum, and then most of the older styles over the last couple of years of helmets had come from European manufacturers, which met another European standard called EN 12492, which is a standard for mountaineering. So the first helmets that were used in construction in the U.S. were mountaineering helmets. And since then, over the last couple of years, many manufacturers have moved to develop Type 2 helmets, which again meet the ANSI and OSHA requirements. And those Type 2 helmets have the impact attenuation, penetration from around circumferentially around the the helmet as well. And so there is a group right now in ISEA, which is the head protection group, and they are working on updating the standard to include more detailed specifications regarding the Type 2 helmets and how they will be referred to in ANSI and OSHA. We were hoping to have that out during the year 2025. It looks like it will be probably some time closer to 2026 when the standard will be updated.
Okay. So my last question, what advice would you give to organizations or workers who are hesitant about transitioning to helmets?
Yeah. So one of the things I would tell you is to go visit a website that was developed specifically for this, which is hardhatstohelmets.org. That provides information, really everything you want to know about the transition to hard hats to helmets. And that website is designed to answer and to deal with the frequently asked questions. What do I deal with in terms of making this transition? Are they hotter? How do they protect me? And, a lot of things that I've described here with you today. So what I describe to, contractors, all over the country is that it's clear the evidence is that helmets offer more protection from traumatic brain injury and skull fracture than the traditional hard hat. And they do this by being engineered to absorb the energy of something that might happen to your head on a job site. Even walking on a level surface, slip, trips, and falls, there's been many serious injuries and fatalities related to that. So whether you're working at height, whether you're working on a flat surface, the clear recommendation is to make the transition from a hard hat to helmet to protect your people's most valuable part of their body, which is their brain. And a lot of the work that's done, physically done by people in the field, are done by trade partners to general contractors, and many of them are small, less than 100-person mom and pop type shops, and many of the larger GCs, and more every year, are requiring their subcontractors to move to helmets. So the pricing pressure, because the helmets are more expensive than hard hats, is taken off somewhat because everybody is on the same playing field. So if you pay the same thing for lumber or concrete, then you're not at a competitive disadvantage. And that's been something that we've been working against, is the price issue. But more and more manufacturers are coming into the market. So the economy scales come in and the price is starting to come down.
Okay. Well, thank you, Scott, for joining us today. And thank you for those of you listening and joining us on this episode of Advancing Excellence. Huge thank you to Scott Greenhaus for sharing his expertise and insights on the evolution of head protection in the construction industry, from the history of the hard hat to the innovative technologies behind modern helmets. It's clear that safety and innovation go hand in hand. If you've enjoyed this episode, please subscribe, leave a review, share it with your network. And for more information about the topics we discussed today, be sure to check out the resources in the description. Until next time, keep striving for excellence in everything you do. Make sure you join me on the next episode of Advancing Excellence. Thank you, Scott.
Thank you.
Thank you for listening to today's episode of the Advancing Excellence podcast. If you have any comments or questions, please get in touch with us at info@aoeteam.com. Don't forget to follow AOE on LinkedIn at Advancing Organizational Excellence, and be sure to subscribe to this podcast so you never miss an episode.